Welcome to the DIY Honda Garage channel. The DTC B1080 indicates an error in the power supply circuit for the Relay Control Module and the Multi-Information Control Unit, MICU, in the 2011 to 2017 Honda Odyssey. This error suggests that there is a malfunction related to the input supply on the IG1 Ignition 1 line, which affects the functioning of multiple electrical components in the vehicle. The Relay Control Module is typically located under the driver's dashboard, connected through a specific wiring harness. It plays a crucial role in controlling various electrical circuits by managing the power supply based on ignition status. The MICU, located in the same region, gathers data from various sensors and controls numerous functions, such as lighting and security. Understanding this error is vital, as it may affect vehicle operations and safety features. The B1080 error relates specifically to the power supply circuit that feeds crucial components like the Relay Control Module and the Multi-Information Control Unit, MICU. The Relay Control Module serves as a conduit for electrical signals, controlling other devices and circuits based on the ignition status of the vehicle. The MICU, which is also connected to this circuit, performs diagnostic checks and operates several of the vehicle's functions, including lighting and security systems. As such, a disruption in power supply can lead to malfunction of these components. These modules are located in the driver's under-dash area, making them relatively accessible for troubleshooting. Overall, even a small error in this circuit can have widespread implications for vehicle operation. The B1080 error can arise due to several potential issues. A primary suspect is a faulty relay control module, which may have failed internally, preventing it from operating correctly. Similarly, bad or loose electrical connections can interrupt the power supply circuit, leading to this DTC being triggered. Furthermore, blown fuses, such as the number C12, 20 amperes under the dash, or the number B6, 7.5 ampere, in the underhood fuse relay box can also result in power interruption to the affected components. Each of these causes can contribute to failures in the circuit, making it essential to check all possible sources of error before any replacements or repairs are made. Understanding the relationship between these components and the DTC is crucial for accurate diagnostics. A range of symptoms may occur due to the B1080 error code. Drivers may notice warning lights illuminated on the dashboard, indicating a malfunction within the vehicle's electric system. Additional electrical malfunctions could occur, affecting various features such as lighting, door locks, and climate control. Since the Relay Control Module regulates multiple electrical systems, any dysfunction can lead to inoperable features, making the vehicle less convenient and potentially unsafe to operate. As such, monitoring these symptoms can guide technicians in diagnosing the root cause of the issue more efficiently. It is essential to regularly check the status of these components to prevent further complications. The first step in troubleshooting DTC B1080 involves clearing the diagnostic trouble codes, DTC, using the Honda Diagnostic System, HDS. This requires the ignition to be set to the lock position and then returned to the on position. Allow the system to initialize for at least 6 seconds. This step is crucial because it resets the system, providing a clean slate for further diagnostics. This ensures that the present status of the vehicle's electrical systems is accurately reflected, allowing for a thorough assessment of any persistent issues. Follow-up checks can reveal if the B1080 error reappears, indicating whether the problem is ongoing or intermittent. After clearing the DTCs, it's necessary to check for any DTCs using the HDS again. If DTC B1080 is still indicated, It confirms that a fault within the power supply circuit still exists. In contrast, if B1080 does not appear, it suggests that the issue may be intermittent. This can often point toward loose or poor connections that could be resolved without extensive repairs. It is essential to document any DTCs that appear during this step for further analysis, as consistent detection of B1080 signifies the need to proceed with deeper diagnostics. Understanding whether this DTC is persistent or an intermittent failure can direct the next steps in troubleshooting. The next step involves ensuring the ignition is turned to the lock position before proceeding. Disconnect the relay control module connector B16P, a critical step to isolate the module from the circuit. Following this disconnection, the ignition switch should be turned to the on position to measure the voltage. It's essential to check the voltage between terminal number 9 of the relay control module connector and body ground. This will determine whether battery voltage is reaching the connector. If voltage is present, it indicates that the power supply is functioning, and the relay control module may need to be replaced. Conversely, if there is no voltage, the issue lies elsewhere in the circuit. If the previous step found no battery voltage, turn the ignition to lock once more and disconnect the driver's under-dash fuse relay box connector B5P. This step is crucial as it will help isolate the problem further. Utilize a jumper wire to connect terminal number 5 from the driver's under-dash fuse relay box connector to the body ground. This method enables a test of the circuit by directly providing a ground reference. Assessing how the system responds with this connection can yield further insights into where the issue might be located. If the system operates correctly when using the jumper wire, it will indicate that the original ground connection was faulty, directing the technician toward remedying this particular issue. After completing all necessary repairs, it is vital to conduct a thorough verification process. This includes rechecking for DTC B1080 using the HDS to ensure that no faults persist. It is also essential to monitor the functionality of all related systems that were affected by the DTC. By confirming that all components are operational and that warning lights are off, one can ascertain that the vehicle is fully restored to normal function. This step is critical for both the technician's confidence in the repair and the driver's assurance that the vehicle is safe to operate. Comprehensive post-repair testing often identifies any lingering issues, ensuring long-term reliability. Preventive maintenance is essential to minimize the likelihood of encountering DTC B1080 in the future. Regular electrical inspections can catch potential issues before they escalate into more significant problems. Technicians should periodically check and replace fuses as needed to ensure they're functioning correctly. Attention to cleanliness at electrical connections also helps maintain good conductivity and reduces the risk of intermittent failures. Properly secured and clean connections can aid in the long-term reliability of the vehicle's electrical system. Employing these preventive measures can save time, money, and ensure the overall safety and functionality of the vehicle. In conclusion, the DTC B1080 highlights a critical issue within the power supply circuit that affects the relay control module and MICU in the Honda Odyssey from 2011 to 2017. A systematic troubleshooting approach is vital to accurately diagnose and resolve this error. Starting with checking fuses and validating connections can often lead to quick fixes, should the issue prove more complicated. Following the detailed steps outlined can facilitate accurate repairs. Lastly, engaging in preventive maintenance practices can greatly reduce the frequency of DTC instances, ensuring the vehicle remains reliable and safe on the road. Driving with confidence is paramount. and understanding the core components of the vehicle is essential for every Honda Odyssey owner. Please like and subscribe to the channel. See you next time!